Hi. When we are using Azure Kubernetes Services, we have some options to scaling our cluster. Basically, when we are scaling our cluster, basically we are scaling the number of the pods or the nodes that we need for our cluster. Okay. In general, we use Horizontal Pod Autoscaler where we scale the number of pods we need for our container, okay? And when we're trying to scale the horizontal pod autoscaler, the cluster trying different approaches, okay? One of them is to create new nodes to support the new replicas, the new nodes. It means when we try to increase the number of pods, our cluster trying to create new virtual machine nodes to deploy these pods, okay? Considering that we have configured the automatic autoscaler for that. Or we have one option here that's to burst to Azure Container Instance. That means the cluster will try to create new pods, will try to deploy new replicas, but will not create a new virtual machine node. It will use a virtual node. A virtual node basically uh, is one resource here that creates the pods in Azure Container Instance. It means each pod that you're trying to deploy will be created like an Azure Container Instance, okay? It will be managed by our cluster, okay? Then it means we are deploy, they will call the virtual node and will deploy fast new pods in the Azure Container Instance, okay? This is the idea that we've shown in this first part of this demo. To do that, we need some elements here in the Azure. The first one we need is to create one container registry to deploy our image. Okay, let's create one container registry. We can call it SCR. I give a name here. Okay, a region. And we can let the other parameters as is and create. Okay. Now here in the container registry, we need to enable some identities and security. Then we can go to access key here and enable the access keys because we use it later, right, for our cluster. And we need to go to identity and enable the system identity for our container registry to be integrated with our cluster. Okay. The other elements we need to create is one log analytics workspace because we will log everything in our cluster. Then we need that. Can create a key one log analytics workspace. Okay, let's create log demo KS. The region here. The other parameters we can have it as is, review and create. And Azure will create for us. Okay, create. It will take a few minutes to be created. I will let it create and back. Okay, Azure created our workspace. And now in our resource group, we have the container registry and the workspace. And we can create our AKS cluster, right? Create here, Kubernetes. Okay, create. Here we need to pay attention to some elements that's important, right? To create the AKS exactly the way we need to scale that later. Okay, here the basically I give one number for our cluster. Cluster. Okay, the region. I will not set any availability zone because it's a demo, okay? I will keep the standard machines here. And in auto scale, I will keep the maximum for 2. It means we will have only 2 virtual machines, nodes in our node group, okay? Click next to node pools. Here in the node pool, we'll create in the agent pool to change the max pods per node configuration. I will set it for 40. I'm reducing the number of the pods that the virtual node can support to make our autoscaler fast, right? Because if you try to deploy more pods, of course, the autoscaler will run fast. And update. And here is a very important part because to enable the virtual node here, right, you need to set here the enable virtual nodes, right? You need to set this configuration here. When we set this configuration here, some information in the next steps will change, right? Because to enable virtual nodes, we need some specific plugins in the Kubernetes, right? Next, authentication. We can keep it as is, okay? Next, networking, and here is the important part. We don't need to change nothing here now, right? But it's important to know that to use virtual node, that's the virtualet plugin, you need to use Azure CNI, okay? When you set the enable virtual nodes, here in the network configuration, it's set at Azure CNI, right? The standard in general when we create a Kubernetes cluster here in the Azure is to use Kubelet. But to use virtual nodes, you need to use Azure CNI because Azure CNI will install some plugins that's required for virtual nodes, okay? We can let the configuration as is here, right? They will create one virtual networking, okay? Next, integration. Here in the integration, we need to choose our container registry. The container hash we have created here is here pod demo. Monitoring, we need to enable the monitoring, okay? And we need to put our log analytics workspace here, right? And we can click next and review and create. Azure will validate, okay? And we'll start creating. Okay, how it takes some minutes to be executed, I stop the video and back when Azure finished the Azure Kubernetes cluster creation. Okay, Azure created our cluster. Let's take a look on that. Here is our AKS cluster, and we have all the configuration for our cluster. Azure already made some deployments here, some workloads. That's part of the cluster configuration, etc. Right? One thing that we need to pay attention here is a basic concept related to what we are doing is when we are trying to use the horizontal pod scaler or the autoscaler in general, right? We need to have some metric server, right? Azure already deployed one metric server in our cluster. The metric server is used to collect the metrics from the cluster or the pods or other elements in the cluster, right? That we can use for monitoring or for autoscaler, for example, right? Here in Azure, when we deploy one Azure Kubernetes service, Azure already deployed one metric server that's related here to the Azure Monitor. It means these metric servers in general collects information like the Azure Monitor inside our cluster and our pods, right? And we can use this metric servers configuration in our cluster, right? To set some configuration for our horizontal pod autoscaling, right? When we're trying to create or deploy a Kubernetes cluster in another place, for example, on-premise or sometimes in another cloud, in general, the metric server is not installed by default, right? Here in Azure, they install the metric server by default because this metric service configuration here is basically provided by Azure Monitor, okay? We have other metric services in the market we can use, right? One of the most used and famous is Prometheus, right? We can use Prometheus to collect many information from your cluster and use later in a dashboard like a Grafana, for example, or use here to set your horizontal pod scaler configuration. Because when we use the horizontal pod scaler, for example, we need to tell to the cluster, right? We need to create one configuration to tell, okay, in which condition I will auto-scaler, right? And this condition basically is based in one metric. What's the metric I use to tell to my cluster that I want to scale, okay? And metric servers use it for that. In this first part of this demo, you use the default metric server, okay? And later we'll show how to use, for example, Prometheus to collect information and to be used in our cluster, auto-scaling and all, okay? Well, other elements is as is, right? We will navigate that according our demo progress, okay? Well, to deploy some pods in our cluster, we need one application. And for this demo, I will clone one application I have in the GitHub, okay? And build a Docker image and deploy in our container registry and later deploy in our cluster, okay? Then the first thing, I will clone the repository I have in GitHub. We get the URL here. Okay, here we have some files. Let me go to the, okay. Here we have some files, right? The application files itself, right? The web application files. And we have some YAML files that we use later to deploy and configure our cluster, right? We have a Docker file here that is being used to build our web application, okay? We can do that using Docker. Then we can use the Docker build to build our container image, dash F our Docker file, dash T. Here is the tag of our image, right? We need to copy the Azure Container Registry server here, right? That will be our image. Let's go to our container registry and copy here the login server. Okay. Slash the name of the repository and column the version of our image and a dot. Our image will be built. It can take some time. It's okay, right? If I use here Docker images, for example, I can see now that I have this one. That is our image, right? We can push and we decide. We can push this image to our container registry using Docker push and, sorry, the image. Docker push and the image. Okay. They failed because the authentication, right? It means I was not able to authenticate here in the container registry. This is the reason we set the access key here when we created our container registry, because we need to first log in our container registry to deploy that. We can do that using Docker login, right? Copy here the server, or we can open here the access key to collect all the information. Okay, the login server here, right? We can come here, put the server, dash U the username here, right? We copy the username here. And dash P the password. The password, we can use one or other here to log in, okay? They will log in our container registry. Okay, login succeed. Now we can push our image again. It takes some minutes, depend of the size of the image, or internet connection, etc. Just wait to be deployed. The last step in general takes some time because the Docker push trying to set some configurations. Okay, now we can check if our image is there in our container registry, right? We can go here in our container registry, we can go in repositories. Okay, we have a repository and we have our image here, right? Good, we have the image we need to use in our Azure Container Registry repository. Okay, now let's connect in our cluster, right, and see some information on that. Let's open our cluster configuration. We can click here in connect, copy the first line that set the subscription. Okay, go to the command line, paste, execute. Okay, and we can copy the second line here to get the credentials to use in our command line. Okay, we can use kubectl to see if everything's okay. Get nodes. Okay, we have our nodes here, right? Our two virtual machine, traditional nodes, and our virtual node here, connected also, created also. Okay, good. What we can do now is create one namespace to be used in our demo. Then we use kubectl, create namespace, website. This is the namespace that we use for our application. Okay, if we can go to the namespace here in our cluster now, we have the website namespace. Okay, what we can do that is make one deployment, right? We can deploy this image we have created in our cluster, right? To create one replica here, and we can do that using our deployment.yaml file, right? But we need first to set the image in our deployment file. We can do that using, for example, the Visual Studio here, right? We can open the file. Okay, this is our deployment file, right? This deployment file basically is using the namespace, the web application like website, okay? I'm deploying two replicas. It means I will deploy two pods, okay? I need to put the image here of our container, okay? I will get it from our, let's open the tab here, for our container registry, okay? We can open the repositories. We can open our repository, our version, and we can copy here this part, right? Copy here, and we can back to our deployment file and update here, right? Replace here with our image. Okay, the application will be running on port 80. And one thing that's very important also when we use horizontal pod autoscaling is we need to set, right, the resource and limits for our pods, right? This is very important because when we are using some metrics, right, like we said a few minutes ago, when we are using some metrics, we need to understand what our pods need, right? To understand if we need to scale or not, right? I put some configuration here, save our file, okay? And I will deploy this file in our cluster. Let's do that here. Okay, this kubectl, deploy, kubectl apply -f, the deployment file, -n, that's the namespace we have created, right? Okay, perfect. Our file was deployed. If we can go to our cluster in the workloads, we see now they have one workload here. We have one deployment, right? It's the website, and the website has 2 pods, right? Because it was what we defined here in our file, right? We have 2 pods. We can click on pods here and filter by our namespace, and we can see we have 2 pods, okay, deployed. One thing interesting here is our 2 pods were deployed in our nodes, our our traditional nodes, right? Virtual machines. One was deployed here, another was deployed here, right? You have 2 pods deployed here in our cluster. What we can do, for example, is to change the number of replicas, right? We can change the numbers of replica to 4, save the file, and deploy again, for example, right? We can increase the number of replicas here. Perfect, right? If we refresh here, we see that now we have 4 pods, right? We have 4 pods deployed in our website namespace here, right? Okay, we have 4 pods, and the 4 pods were deployed in the virtual machine, right? Because the cluster is not using yet the horizontal pod scaler based on the virtual node because we not configured that, okay? Okay. The first thing we need to configure that, right, to use the virtual node, is to change the way that you make the deployment. It means we need to include some information in our deployment file here, right? We need to set some information that's important, mainly the tolerations and the affinity that is tells to the Kubernetes cluster how the pods will be deployed and where to be deployed, right? Basically, I will copy some configurations to the file, right? Here. Okay, basically the toleration, we need this information to tell that we will use the virtual kubelet, and the affinity to tell how the pods will be deployed, right? We have this information here. We can save our file, okay? Save, and deploy it again. Okay, take a look at our cluster again. Open here. Oh, this is the namespace. Let's back to the cluster here and open the workloads, the pods, the website, and it's okay, right? They are trying to basically deploy some information in our cluster, right? They are trying to some information in our cluster, and they trying to deploy some information, some pods in our virtual node, right? They are trying to terminating something in the traditional and deploying virtual nodes because now we have it configured, right? But it probably failed, right? We can open here the pod that has failed, and we can see how the pod was failed, right? And here we see one information that said inaccessible image. The image in the container registry is not accessible, right? It means the pod failed because the cluster is not able to get the image from the Azure Container Registry, right? Why it happens? Well, it happens because when we deployed the image here in the traditional virtual node, okay, the cluster used the service principal to connect to Azure Container Registry and get the image, right? At the moment I'm recording this video, the virtual nodes, the virtualet configuration, don't have an integration with the service principal, right? It means that we need to create some secret, right, to connect our cluster to the Azure Container Registry by virtual nodes, right? Basically, what we do is to tell to the cluster what is the user and password to connect to Azure Container Registry by the virtual let, right? Plugin, the virtual node plugin. We can do that here in the command line, right? Basically, what you need to do is create a secret like kubectl, create a secret. The type of secret we want to create, that's the Docker registry. Okay. The name of the secret, kubectl create secret Docker has the name of the secret, -- Docker server. Okay, we need to put the Docker server. That's our it's our container registry, right here. Let's back here. Let's go to the access key. We can collect all the information. This is the server, right? Back here. Oops. Back here, Docker server. We need to -- Docker username, right? That you can get from here, the username. Okay. -- Docker password. And we can get one password here. Okay. And we need to put one email, Docker email. You can put any email. I put my email here. Okay. And -n, the name of the namespace we are using. That's website. Okay, the secret was created. If you go to our cluster, for example, here in the configuration, secrets, and filter by our namespace, we see that we have one secret here, right? Now we need to tell to our deployment how to use this secret to get the image, right? To get the image from our container registry, right? We can back to our deployment, and for example, we can put here, for example, the element named image pool secrets, and the name of our secret is regret. Okay, basically what we are telling to our deployment is to get the image we need to use as secrets, and this is the secret we have created. Okay, file save, and we can try to deploy our file again. Okay, kubectl apply -f deployment. Okay, in our namespace. Okay, was deployed, and if we back to our cluster, probably the cluster will try to upload the new informations and will try to deploy the new pods, right? They're trying to deploy the new pods. We can come here, filter, and see that now the status of our new pods is creating, right? It means our cluster is terminating some pods, create a new one, right? It's part of the deployment. In a few moments, if we back here, we see just the pods that are running, right? It means they are creating now. They are not failing because they now can get the information from the container registry, right? And one interesting thing, if we can go, for example, to our research group, let's go another tab here and go to our research group, right? Not this one, but the research group that's created for the network elements here, right? We can see that the Azure will creating new container instances, right? And we'll create a new container instance for each pod that we have, right? Means they are trying to create. Oh, it's running now. We have our pods running now, and we can see in our research group we have 2 container instances created. It means some pods are working in our virtual machine, and 2 pods are running in our virtual node. That means they are running in the container, the Azure Container Instance. Okay, it's okay. We can scale these pods, right? We can do it manually, for example, right? You can say kubectl scale, kubectl scale, deployment, the name of deployment, that's website, and the number of replicas we want. We can put here, for example, 10 replicas, it means 10 pods, -n, and the name of our namespace, right? When I do that, we're trying to scale. If we refresh here, the pod will trying to scale, right? Our deployment, our pods, they are creating again, right? New elements, and you can see that now they are trying to create new pods in the virtual node. It means they're trying to create a new Azure Container Instance, right? That's fast, then create, for example, a traditional virtual machine. We can refresh. In a few moments, we will have new pods running, right? If you go to research group and also refresh, yes, we can see we have more container instance deployed, right? It means our configuration is working, okay? Well, this was made manually, right? I'm scaling here manually, say, okay, I need more pods, please scale to this number of pods, right? But the big advantage of using the scale is to use the auto scaling, right? It means it's made automatically by us based on some configuration, right? To do that, we need to configure some deployment, some configuration to our cluster to use the horizontal pod auto-scaling, okay? We can do that using a file, right? I have a file here. I have one file named website HPA YAML, right? I open it in the Visual Studio also, okay? This is the file that I use to enable the auto-scaling, right, for our horizontal pod autoscaler, right? And in this configuration, I'm setting that I want a max replica to, I don't know, let's set first here for 6, minimum replicas for 4. It means that I'm setting for 4 pods minimum and 6 pods maximum, right? Here's the name of the deployment they want to set the auto-scaling. And this is the metric, right? This is the very important thing because how I mentioned a few minutes ago, this metric is collected by the metric server, right? It means some metrics that Azure has in the metric service can be used in here, like, for example, memory and utilization, right? This configuration says that if the average of the memory utilization is 50% or higher, right, scale to this configuration, right? It sets the environment for this configuration, okay? If you use Prometheus, for example, right, another metric server, you can have a different metrics here to use. You can use a lot of metrics, right? But I'll show it in another video, right? Okay, I will set the information, I save the file, and I will deploy this file to our cluster, right? The same way, kubectl apply -f. The name of file is website HPA, and the namespace, right? Okay, perfect. It was deployed. If I go to our cluster, okay, refresh here the pods. Okay, the pods is running. The 10 pods is running now. If I go to workloads here, then the deployments. Okay, everything is running. And what will happen is now that we set the HPA, we need to see how HPA is working. We can go here and in the command line say kubectl get HPA, for example, our namespace. Okay, this is the configuration we deployed, right? We deployed for this deployment, and we set our metric like our threshold, like 50%. Okay, If the cluster reach 50% of memory average utilization for all the pods of this deployment, right, we will have this configuration running. It means 4 min pods, 6 max pods, etc., right? And if you take a look again in our pods, the website, okay, we see that we have our pods running, no problem. Okay, what we can do is to reduce the threshold from 50% to something ridiculous, right? Just to force our scaling works here, just to see it working, right? Say if our pod's memory is in 7%, we can try to put, I don't know, 5% in our configuration file, okay? Let's put here 5%, save, and deploy again, okay? I will deploy again. Perfect, and I can get the HPA again. Okay, now we can see that the average memory utilization is 7%, and our threshold is 5%. It means that in a few seconds, the cluster will start adjusting the configuration of the pods, right, for our deployment here, right? Refresh. Okay, nothing happens, but in a few moments, something will start changing, right? Because the metric service, it works in a few seconds. If I'm not wrong, it works in 30 seconds, something like that, right? In each 30 seconds or something like that, or 10 seconds, that we start running, right? In a few moments, we will see our cluster will be changing the configuration that we have for our website, right? Okay, we have 6. Let's see what our file probably will have the maximum here. Okay, maximum is there. Let's try to put the maximum like 15, for example, right? And deploy again, and you see something changing. Because we are telling that if the average is 5% or more utilization, we need the 15 replicas, right? Okay, let's save, and let's deploy it again to take a look at what happens, right? We're deploying again, and we see the HPA. See, okay, we need 15 pods, right? If we reach this threshold, based on what we are seeing, we already reached this threshold, right? We can back to our cluster and see what will happen here, right? In a few moments. Okay, good, right? Now the cluster will try to deploy more replicas because the autoscaling is working, right? Say, well, I have more than 5% utilization, right? Then they will try to deploy new pods for us, right? They're creating, and are creating again, okay, in the virtual node. It means they are deploying more Azure Container Instance to support our demand, right? They will try to create here, and we will make all the process we had before, right? No problem. They will start creating here. In a few moments, we will have our pods here, right? You see they are trying to create some replicas, and every configuration we deploy, they will try to implement in a few seconds, right? Okay, they are deploying. And it works, right? Good. What we can see when they are deploying is to deploy one service, right? Service will create one ingress for our application, right? And we can open it in the web. Let's go to here and see that we have a service YAML file. We can edit the service also. Service, okay. And see everything is okay because you are using the website, the target port, etc. We can deploy this file, right, using kubectl apply -f service, okay, dash n the website. Perfect. If you back to our cluster, what will you see in the service here I got now? is that we have one new service here that is being created, like a load balance. And in a few moments, we will have one IP that we can access our application, okay? Okay, we can click here and see that our application probably is running, right? It takes some time to configure everything. Let's wait a little bit and try to access. In a few moments, our application will start because they are configuring the load balancing and everything, right? If I go to the resource group, they see they are creating some load balancer and IPs and other elements necessary to run our application. Okay, our application is running in our cluster, right? Perfect. This is our application. The image is running, right? The image is running, the service was created, and we see the workloads. We have everything here configured. Perfect, right? The next time that the autoscaling run, they will check again the configuration file we have set it, and we run again the autoscaling based on the configuration, right? Okay, everything is running here in the virtual node and etc. Right? Good. Our file, we put 15. The next time the autoscaling run, that you see that, right? And you're trying to scale again. If you see the HPA again, let's see the situation. Okay, we are 5.5 now, right? This is the reason that they are keeping this like this, right? 5.5 now, okay? Basically, if we reduce or we increase the threshold here, probably the autoscale will reduce our pods, right? We can try to do that to put the utilization back to 50%, right? Deploy again. Check again. Okay, what will happen here in a few moments, the autoscaling will decrease the number of pods that we have, right? You can go to the cluster, and in a few moments, we'll see the number of pods will be decreased, right? It takes some time to happen, right? To increase the number of pods is really fast. To decrease the number of pods take a time because the autoscaler really check everything to see if it can decrease the number of pods. It takes some time, but it will happen, right? In a few moments, you can back here and see that everything will be decreased. Okay, after a few minutes, we see that the website deployment decreased the number of the pods, right? Okay, we can see here some pods are being terminating, right? It's based on our HPA configuration, right? How I mentioned, to increase is really, really fast. To decrease is slow, right? It's normal behavior, okay? And our deployments now have 5 pods, and we can check our application to see, for example, if our application is still running, okay? Let's go to the service. And open our application again, and our application is running in our cluster. Perfect. Okay. Well, this is our demo for this video. Okay. In the future videos, I will show you how you can configure Prometheus, right, to use more metrics than the default metrics that's provided to the metrics server. Thank you.